Hello students, how are you? So I'm Akash Gupta again, and as promised, I'm here with this second strategy video for term 2 physics. Okay, and as I promised, I will talk about problems today. So we have 5 very important problems for term 2, and I also have few very special techniques and concepts that will help you in your JEE and NEET exams too. Okay, so let's not waste time, let's begin. And I hope you all are aware about the new war between Russia and Ukraine. So I hope there is something very important for us too. Russian men invaded Ukraine with X-ray guns. This is a hypothetical concept. Obviously, they are not using X-ray guns. There are no useful X-ray guns actually. But suppose they are using X-ray guns. So what is here for us? You can remember R stands for radio waves, right? M stands for microwaves, I for infrared, V for visible, U for ultraviolet, right? X for X-rays and G for gamma rays. And this is the correct sequence of increasing order of frequency for electromagnetic radiations, and it becomes very easy to remember this, and believe me, it is very important for you to remember this sequence. It is also the decreasing order of wavelength, and it is increasing order of frequency. So by remembering this simple line, you can remember the correct order of electromagnetic spectrum. Okay. Next, I also see many students have trouble when it comes to image formation by spherical mirrors. They are, let me tell you, they are useful for NEET and JEE exams. Okay, so suppose we have a spherical mirror. So this is this curve represents a spherical mirror. If you polish it from inside, it becomes a convex mirror, and if you polish it from outside, it becomes a concave mirror. This is focus, and this is center for curvature, center of curvature. Okay. And this represents a principal axis. Okay, any line which passes through center of curvature is principal axis. So let us draw a new line, this yellow line, and it can be principal axis too, because it is passing through center of curvature. Okay, so as there are 4 important regions, this point is called pole. So we have a region beyond pole. We have a region between pole and focus. We have a region between focus and center, and we have a region beyond center of curvature. So basically there are 4 regions. Okay. I hope you remember a very important formula that is called Newton's formula, and it says xy equals to f square. Okay, and where x and y are basically object and image distances, but not for pole, not from pole, because if they are measured from pole, you have a different formula which says 1 by v plus 1 by u equals to 1 by f. If x and y, the object distance and image distances, are measured from focus, the formula between them becomes xy equals to f square, where x is object distance from focus and y is image distance from focus. Okay, as the product x times y is square of focus, it is always positive, and if it is always positive, it says x and y, they both can only be positive, or they both can be negative. One positive, one negative is not possible. Means if we have object and image, they will either be on the right side of the focus or on the left side of the focus. Okay, so let us take an object here. You have to just remember the 2 important pairs. The one is this. Suppose we have an object on this yellow line, that is 1. Then its conjugate point is here. It is 1 dash. Just remember, if we have a point here, its conjugate point is here. Okay, and if we have a point here, 2, its conjugate point is here, 2 dash. Remember this. Okay, because if object is on the right side of focus, the image cannot be on the left side. So therefore 1 and 1 dash are on one side of focus, and 2 and 2 dash are on other side of the focus. Just remember these 4 points. These 4 points are the main theme of this situation. 1 and 1 dash are actually conjugate points. So if 1 is object, 1 dash is image, and if 1 dash is object, 1 is image. Similarly, if 2 is object, 2 dash is your image, and if 2 dash is object, 2 is your image. Okay. So how we can answer every case related to spherical mirrors by using just this simple concept? Let us think. Okay. If we polish this curve from outside, it becomes a concave mirror. Okay. And let us just mark those points again. 1, 1 dash, 2 and 2 dash. This is pole. As we can have a real light here, the light behind the polishing cannot exist. So it becomes virtual side, it becomes real side. Okay. And suppose they ask you, place an object between center and focus, and where is the image? Just remember, if object is between center and focus, its image is going to be its conjugate point, that is 1 dash. So image is, see, image is beyond center of curvature. It is bigger because you can see this line is smaller, this line is bigger. So image is simply bigger. Image is real, object is also real, image is real because they both are in real region, and that is the answer. If they say object is beyond center, somewhere here, its image is simply between center and focus. The image is smaller. Again, image is inverted because this is downside, this is upside. Image is inverted, image is smaller, and image is real. So it is a real pair, right? It is a real pair. If they say, what happens if we have a real object between pole and focus? So if we have object between pole and focus, its image is on this side because this 2 dash is actually the conjugate point of 2. So this is image. This image is erect because they both are on the same side of principal axis. So this is image. Image is bigger, as you all can see, image is bigger. Image is virtual because it is in virtual side, right? So that is your answer. If object is here, image is 2 dash, image is erect, image is virtual, image is erect. Isn't this simple? Okay. So if they ask you, the last case, if they ask you, if we have an object here, if an object is here, it is definitely virtual. Okay. And if object is virtual, here beyond pole, the image would be between pole and focus. Between pole and focus, image will be erect, image will be smaller, and image will be real, right? So by remembering these 4 points, you can answer any questions related to image formation by spherical mirrors. And that's not the end of the story. Okay. If you polish from inside, it becomes a convex mirror. Okay. It becomes a convex mirror. If it becomes a convex mirror, this becomes your real side. And it becomes virtual side. If you want to place a real object in front of a convex mirror, you can place only on this side. So if you have an object here, actually it was 2 dash, I think you remember. Its image is going to be here. And now you see the image of 2 dash is erect. It is smaller and it is between pole and focus, and it is virtual because this time it is on the virtual side. So with convex mirror, if we have real object, we have a single case. If we have a real object, its image is going to be between pole and focus. Image is smaller and image is virtual. But here too, if we have an object at 2, the image is here, right? So if we have an object here, it must be a virtual object, and image is erect, image is real, image is bigger. We also can have objects here and here. So if it is 1, it is 1 dash, okay? And if an object is here, its image is here, but they both are virtual in the case of convex mirror. If we have an object here, this is the image, and they both are virtual in the case of convex mirror. So in convex mirror with real objects, we have only a single case. Virtual image, smaller image and erect image. But with virtual objects, virtual image, we can have as many as cases as we had with concave mirror. Okay. So that is the end of the story of image formation. I hope this concept will help you a lot in answering the questions, answering the many theoretical questions. Okay. Now we will take few very important board level problems that will surely help you in your term 2 exam. So in the first, remember this, in board they often ask you the questions related to combinations of lenses, and always remember, when they have lenses in sequence, if the lenses are attached without any gap, if the thin lenses are attached without any gap, you have to combine them by using combined focal length formula and make them a single lens and use lens formula. But if they have lenses placed at some separation, you have to take one lens, then second lens, then third lens, take refractions through each lenses in sequence, and you make the image. So suppose we have, this was a question previously asked in board exam, and let us see how to solve this. So here we have three lenses, three converging lenses. Each lens has 20 centimeter focal length. We have an object at a distance of 40 centimeter from first lens, and we have its image at a distance of 20 centimeter from the last lens. So they are asking us what are the separations between lenses. Okay, let's answer first. Okay, as you can see, every lens here has a focal length 20 centimeter. So we have to make final image at this point 20 centimeter from the last lens. So actually this is focus. The last lens can make image here only if the lights from L2 fall on L3 parallel to principal axis or parallel to themselves. Okay, so the lights must be a parallel beam from L2. Okay, so that is the hint. Light from L2 must be a parallel beam. Okay, and if we solve for L1, see, for L1 the focal length is 20 centimeter, the object distance is minus 40. Let us use lens formula. So for lens formula we have 1 by V minus 1 by U, U is minus 40. Okay, and 1 by F, which is 20. You solve this and you will get V equals to 40. So we have image of object by first lens at 40 centimeter. So just try to imagine the scenario. If we take the first lens, say object is here at 40 centimeter, its image is formed at 40 centimeter on the right. You also, I think, remember, if the object is at 2f distance from lens, its image is at equal distance to f on the other side. So this is the first object. You can say this is the first image. And this first image becomes the object for the second lens. As the second lens has to refract these light waves parallelly. Okay, so I think you can easily digest this. As the light rays have to become parallel after refraction, the light rays must come from its focus. So this distance must be equal to focus of the lens. So as focal length is 20 centimeter, this is equal to 20 centimeter, and that says the distance between L1 and L2 is 40 plus 20, that is 60 centimeter. Distance between L1 and L2 is 60 centimeter. And as the rays from L2 are actually a parallel beam, right? If the rays from L2 are parallel beam, they will remain parallel whatever be the distance of L3 from L2. So there is no conditions between distance between L1 and L3. The distance between L2 and L3 and the distance between L2 and L3 can take any value. So distance between L2 and L3 can take any value. Okay, so that is the answer for this question. But remember, when you answer this in boards, you have to write the whole solution very clearly. Write each and every step, showing each and every refraction separately. Okay, write all the concepts, write all the arguments I tell you in detail, in proper language, and then only you will get full marks. This was a 5 marks question, and obviously I find when they ask you combinations of lenses, many students find it very difficult. So practice with these kind of questions. Okay, let's see what we have next. Okay, next we have a question from total internal reflection, and they are asking us if light rays are incident on a prism like this, on a right angle isosceles prism like this, and light rays have 3 mixture. In fact, light rays have a mixture of 3 lights, and the refractive index of the material of the prism is different for the 3 lights. For one it is 1.39, for other it is 1.47, and for other it is, for next it is 1.52. Then they are asking us find which of the these rays will suffer total internal reflection and which ray will suffer refraction from the face, from the hypotenuse AC. Okay. See, as all the rays are falling on first surface normally, just make them fall. So after first refraction, they will go undeviated. I must say they will go undeviated without any deviation, and they are going to incident on face AC. Now there is a doubt whether they can cross, whether they cross face AC or just get totally internally reflected. Let me tell you a very simple technique. Okay, just imagine, just take a case that all rays refract, all rays go on the other side. And if all rays go on the other side, Snell's law is valid for all of them. So let me write Snell's law here. As the geometry says, this angle must be 45. So every ray on AC is being incident at an angle 45 degree. So let's write the refractive index, then write sine 45, then write refractive index of air, that is 1, and sine r, where r is the angle of refraction on outside or in air. Okay. Now let us see what is the value of sine r. So sine r equals n sine 45. N divided by, what is sine 45? Sine 45 is 1 by root 2, and root 2 is 1.414. Now imagine, if I take the first ray, and for the first ray, the refractive index of prism is 1.39 only. If you place 1.39, imagine, this ratio is less than 1. And if sine r is less than 1, then only r exists. So r exists for first ray. For first ray, r exists. And if r exists, the first ray is going to penetrate, going to refract in air, or you can say the first ray will get refracted. Okay. If we take the second and third ray and put their refractive indices, put their corresponding refractive indices 1.47, 1.52. If you put 1.47 and 1.52 here, you get a value more than 1, and you know sine r more than 1, the value of sine r more than 1 is not possible. Sine r is always less than 1. Okay. So it is impossible. The Snell's law is simply not valid for second ray and third ray, so they will not be refracted. And if they are not refracted, they will actually totally internally reflected like this. So the second and third ray will suffer TIR and the first ray suffers refraction. So whenever you have a doubt whether the rays are going to have a refraction or they are going to undergo total internal reflection, my suggestion is you just apply Snell's law, and if you see the angle of refraction, sine of angle of refraction less than 1, definitely the rays are being refracted. And if you see the value of this minus sign may confuse you, so let me. Okay, and if you see the value of sin r is coming out to be more than 1, so definitely the sin r is not possible. So the refraction is not taking place, the angle of refraction is not existing there. So therefore, you can surely say the TIR is taking place for those rays. Okay, so that is the answer for this question. Let us proceed for the next one. Okay, here we have an electron is accelerated through a potential difference of 100 volt. So if an electron is accelerated by a potential difference of 100 volt, the work done on that electron is going to be the electronic charge times potential difference, which is 100 volt. Okay, if this is the work done is converted into kinetic energy of electron. Now we have kinetic energy, and I think you remember the formula for de-Broglie wavelength, which is lambda d equals h divided by momentum. If we know the kinetic energy of a particle, the momentum can be written as square root of 2m and kinetic energy, which is equal to Ek. So that is the formula for de-Broglie wavelength if a particle's mass, charge and kinetic energy is known. So you can use this formula and find de Broglie wavelength for any particle like electron, proton and alpha particle, whatever be the particle. But for electron, as electron is very popular in questions, for electron, if we place here the mass of electron, if we place here the charge of electron, okay, this is actually V, okay. If we place the charge of electron and if we place here the value of voltage in volts, this formula is converted into a square root of 150 divided by V, and the answer automatically comes in angstrom. So always remember, this is valid for any kind of charged particle, but this is only valid for electron, only valid for electron. So if you want to calculate the de Broglie wavelength of an electron which is accelerated by some potential difference V, you can use this formula for electrons, and simply just the de Broglie wavelength would be a square root of 150 divided by 100, and the answer is going to be in angstrom. So that is your answer. You can calculate it very easily. It will be something 1.2 or something like. So let's move further. Now this is again a very important question. Whenever they ask you some questions in atomic structure, the first thought that comes in their mind is Rydberg formula. So whenever they say find the wavelength of any spectral line, whether it is of Lyman line or Balmer line, always use Rydberg formula, and Rydberg formula is actually 1 upon lambda equals r z square and 1 by n square minus 1 by m square. Okay. Here we assume the electron jumps from a higher energy level to a lower energy level, and actually as electron jumps from m to n, and m is more than n, so it explains the electron is jumping from higher energy level to lower energy level. Now as you know, they are asking you the wavelength of a spectral line of first line of Balmer series. first member of the Lyman series and of the Balmer series. For Lyman series, always remember the Lyman series gives you an idea that electron is jumping into ground state. So your lower state is actually 1. And as they are talking about the first member, the first term, the first member of Lyman series, the electron must have jumped from 2 to 1. So M is 2 here. Okay. As they haven't specified what atom it is, we will simply assume it is hydrogen atom. Okay. And the first wavelength lambda 1 becomes R. For hydrogen Z is 1. So I'll place the value of N as 1 minus 1 upon 2 square. And if you solve this, you can easily find the first member wavelength of Lyman series. Okay. But if we talk about Balmer series, the Balmer series is associated with all the transitions taking place, and electron is falling into n equals to 2. Electron is falling into the second orbit. So the lower orbit, which is n, is actually 2. And as they are asking us the wavelength of first line, the electron must jump from 3 to 2. Okay, just from the next level to the previous level. So from 3 to 2, so M is 3 here. Okay, and if we want to calculate the wavelength, 1 by lambda equals R 1 by 2 square minus 1 by 3 square. Just put the value of Rydberg constant here. Rydberg constant, I think you remember, it is 1.01 times 10 to the power 7 in SI units, right? And it is also given in the question. Definitely they have given the question, or on the front page of the question paper, they will be giving you the value of Rydberg constant. So this way you can calculate the two required wavelengths of Lyman series and Balmer series. So always practice for this formula and few more relevant questions, and let's see what we have next. This is again a very frequent question. I've seen many times they ask you what is the term activity. So it is again a 5 marks question, and it says define the term activity. Okay. Write the expression for the law of radioactive decay in terms of activity of a given sample. So if you want to answer the first question, just write clearly the law of activity, which says minus dN by dt equals lambda n. You know that this is called activity. This is the rate of decay. It is called activity. So define properly that the rate of decay of particles is called activity. It is also symbolized that as A, or it is also symbolized by letter R. It has a unit. Its SI unit is decay per second. You have to write each and everything in your description. Otherwise, they are going to deduct your marks. Okay. So write the law correctly, define the term activity. It is actually decays per second. Remember, they are decays per second. And then in the next question, they ask you, a radioactive isotope has a half-life of T years. How long will it take to the activity to reduce to 3.125 of its original value? So I hope you remember, if you integrate this formula, then you have two results. One of them is n equals to n naught divided by 2 to the power n, where n is number of half-lives. Okay, n is actually number of half-lives. And this formula is also valid in terms of activity. So instantaneous activity is actually the initial activity divided by 2 to the power n. If you place here the value of initial activity and the present activity, so as present activity is only I think 3.125, so it is 3.125 divided by 100 times of the initial activity, which is A naught equals A naught divided by 2 to the power n. So from here, you know 2 to the power n equals 100 divided by 3.125 and it is equal to 32, which is actually to the power 5. So n equals to 5. So you can say 5 half-lives will it take for the activity to reduce to 3.125% of the initial activity. So the correct answer for this is actually n equals to 5. So time is actually n times half-life. That is your answer. And never forget to answer any part of the question, as they are asking you one more part, and it says when a nucleus X undergoes beta decay, and it transforms to another nucleus Y, X transforms to Y by decaying with a beta decay, does the pair XY form isotope or isobar or isotones? Okay. So obviously the question is very simple. As you know, when a nucleus X decays to Y by beta decay, the mass number does not change. If beta decay is a beta minus decay, beta negative decay, actually the atomic number increases by 1. And if it is a beta positive decay, the atomic number decreases by 1. Always remember. But mass number remains unchanged. Okay. Because the total number of nucleons remains unchanged. So that is why if mass number is same, the pair XY is an isobar. So these are the 5 very important questions for your term 2. Okay, I hope you are going to do best in your exams and I wish you all the best. Thank you so much.